I welcome you to the first session of permutation and combinations. In this session, we will take a look at the fundamental principle of counting. What is fundamental principle of counting? Now, suppose we have a man who has a certain number of jobs to perform. Let us say the first job can be done in M1 ways, the second can be done in M2 ways, and the third can be done in M3 ways, and so on. Then the number of ways of performing all the jobs, mind you, if he has to perform all the jobs, in this case there are only three jobs. So if he has to perform all the three jobs, the number of ways will be given by a product of all these three. So we have M1 into M2 into M3 and so on. If there were more jobs, we would have multiplied those number of ways also. Similarly, if he has to perform only one of the jobs, then the total number of ways will be given by the sum of all these three, M1 plus M2 plus M3. Let us solve some questions to understand this better. If a man can travel from A to B via C, and if there are 5 routes from A to C and 4 routes from B to C, in how many ways can he travel from A to C? Let us draw a schematic representation first. We have A, we have C, and we have B. The man has to travel from A to B via C. How many routes are there? There are 5 routes from A to C and there are 4 routes from C to B. So obviously how many jobs are required to be done? He has to do 2 jobs. One, travel from A to C, and second, travel from C to B. The first job can be done in 5 ways. The second job can be done in 4 ways, and because both these jobs have to be performed, therefore we multiply 5 into 4 is equal to 20. Let us solve another question. A class has 10 boys and 15 girls. If one class representative is selected from boys and another from girls, in how many ways can the two representatives be selected? Again, number of ways of selecting a boy representative, that is 10. Because there are 10 boys, we have to select one of them, we have 10 choices. Similarly, the number of ways of selecting a girl representative, we have 15 choices, so 15 ways. And because these are two different jobs and both have to be performed, so we have to select a boy representative and we have to select a girl representatives. Therefore, the boy representative, who can be chosen in 10 ways and is replaced by a multiplication sign. Remember, in mathematics, and is generally replaced by a multiplication sign, and wherever you have an or should always be replaced by an addition sign. So one boy can be selected in 10 ways and one girl can be selected in 15 ways. Overall, there are 150 ways of selecting them. Another question. A boy has to appear for an interview. He has 5 choices of shirts to wear, 3 choices of trousers to wear, and 4 choices of shoes. In how many ways can he dress himself up for the interview? Here, I am trying to show you different situations where the same concept of fundamental principle of counting is being applied. So how many jobs are there? There are 3 jobs here. Number 1, he has to choose a shirt. Number 2, he has to choose a trouser. Number 3, he has to choose a shoe. So number of ways of choosing a shirt? 5. Number of ways of choosing a trouser? 3. Number of ways of choosing a shoe is 4. And because all the 3 jobs are done, one shirt and one trouser and one shoe has to be chosen. One shirt can be chosen in 5 ways and is replaced by that multiplication sign. One trouser can be selected in 3 ways and is replaced by again another multiplication sign. And shoes can be selected in 4 ways. The total number of ways is 5 into 3 into 4, that is equal to 60. Let us take a look at another simple question. A man has to travel from Bhopal to Indore. He can either travel by train or travel by bus or travel by airplane. In how many ways can he travel from Bhopal to Indore if there are 5 trains which ply between Bhopal and Indore and there are 6 buses and 4 flights? Now, the key question here is whether there are 3 jobs to be performed. No, there aren't 3 jobs to be performed. There is only one job, that is to travel from Bhopal to Indore. And there are 3 choices. Either the man can travel by train, or by bus, or by airplane. How many ways of travel by train? 5. Or how many ways of travel by bus? 6. Or how many ways of travel by plane? There are 4 ways of travel by plane. And again, in mathematics, as I already told you, or is replaced by an addition sign. So we have 5 plus 6 plus 4. He has to choose any one of the 3 choices. So either he'll choose a train or a bus or a plane. There is only one job to be performed. This is the key point to be remembered here. And what is the total number of ways? The total number of ways is 5 plus 6 plus 4, that is 15 ways. Another question. A class has 10 boys and 15 girls. If one class representative is selected from boys and another from girls, in how many ways can the 2 representatives be selected if a girl Radha does not want to work as CR with 2 boys, Mehul and Angad, while a boy Ajay does not want to work as CR with 3 girls, Rama, Ranjana and Romila? So far, we have solved questions only without any restrictions. Now, this is one question where there are restrictions. To solve such a question, first of all, assume there are no restrictions. So, we have to select one boy from 10 boys and one girl from 15 girls. There are 2 jobs to be done. So, 10 into 15 is the total number of ways of selecting both class representatives without any restrictions. That is 150. Now, we should subtract the number of teams that cannot be formed because there are restrictions. There are some teams that cannot be formed. Radha cannot form 2 teams and Ajay cannot form 3 teams. Let us see which teams. Radha and Mehul, this team cannot be formed. Radha Angad, this team also cannot be formed. Similarly, Ajay and Rama, Ajay and Ranjana, and Ajay and Romila, these 3 teams also cannot be formed. So out of 150, these 5 teams cannot be formed. And therefore, the total number of ways remaining is equal to 150 minus 5, that is 145 ways. So with this, we come to an end of the first session on permutation and combination. If you have any feedback or any queries, feel free to write to us at studentservices@pfindia.com. Thank you.